Let's start by this example. We have this fixed from one side beam, free from the other side, with total length of 6 meters, and we have two vertical forces of 8 kN each at distance of 3 meters and 6 meters. And we want to draw the shear force diagram and bending moment diagram for it. We will start as always by drawing the free body diagram for the beam. So we have this beam, and we have these 3 points where we are going to calculate. We have one vertical force here of 8 kN, another force here of 8 kN, and here this is a fixed support, so we have a vertical reaction, we'll call it YC, and we have a horizontal reaction, let's call it XC, and we have a moment reaction, let's call it MC. We will start by the easiest equation we have, which is sigma forces at x direction equals to 0, and we don't have any horizontal forces here, any horizontal external forces, so this means that the reaction in the x direction will equal to 0 also. Our next equation is sigma forces in y direction, which equals to 0 also, which means that YC will equal to the 8 plus the other 8 kN, which will equal to 16 kN, and the other forces are going downward, so the reaction is going upward. Let's calculate the moment MC, which will equal to 8 multiplied by 3 plus 8 multiplied by 6. In order to calculate it, we have this force here multiplied by this distance, and we have this force multiplied by this distance. This will equal to 72 kN meter. Let's check now the signs. This moment are going in this direction now. It is going clockwise, which means it is creating tension at the upper side and compression at the lower side. So this means it is negative sign moment. Now we can start drawing our diagrams. We'll start by drawing our beam again. We have here the 8 kN force. Here we have the 8 kN force. And we know that the reaction now is 16 kN vertical and 72 kN meter of moment here. We want to start drawing the shear force diagram and bending moment diagrams. Let's start first by the shear force diagrams. We will start from the left. First force we will face is the reaction. It's 16 kN and going upward from the left side, which means it is positive. So we will go upward here, and there are no any other vertical forces here, so we'll keep going horizontal till we reach this point where there is this 8 kN going downward. So from here we will go downward. This is the 16 kN, and we will go downward here till we reach the 8 kN. We'll keep going horizontal again till we reach the other 8 kN, and we'll go downward and it will reach to the 0. And it means that all the shear force is positive here. Let's check now our bending moment. We have our beam here. Let's start calculating the moment from here. It is 0. Let's start calculating by the next point. Here we have this 8 kN multiplied by 3, so it means we have 24 kN, and we learned that it is negative, because it is creating tension at the upper side and compression at the lower side. So we have here the 24 kilonewton. Let's calculate here. It's from the left side already determined to be 72 kilonewton meter, and if we calculate from the right side, it will come to the same value again. So we have here the 72 kilonewton meter, and we will just connect the points here. So it means that all this moment is in negative direction. So this was it for our first example. Thank you.